Showtime!
Ladies and gentlemen, please make your way to your seats.
Showtime!
Please make your way to your seats. The show is about to begin.
Showtime!
Let the magic begin.
Warp drive.
Yes.
So read this article. Warp drive is just around the corner. What does that mean?
Yeah, just around the corner. Just around the corner, I'd say like 50 years away around the corner. But that's just me. But here's the thing. So as you know, the concept warp drive was first introduced in Star Trek, allowing for travel that's faster than light. It was then again visited in a show called Eureka, where they were testing an FTL drive with a catcher and all that sort of stuff. So there are some great TV shows that have captured the concept. So the thing is, in 1994, theoretical physicist, and I hope I pronounce his name right, Miguel Alcubierre, he proposed a theoretical concept, and it's called the Alcubierre drive, where the spacecraft could travel within a warp bubble that contracts space in front and expands it behind, moving the ship faster than light without violating relativity. Interesting. So, while theoretically sound, up until whenever this article was published or the work was done, it was thought to require exotic matter that didn't exist. However, a team at NASA's Eagle Works lab successfully produced microscopic warp bubbles in plasma using electromagnetic fields, demonstrating the geometry proposed by Alcubierre. So the exact mechanism that they used to generate the warp bubbles involved a specialized laser to excite a cloud of hydrogen plasma into kind of a donut-shaped field configuration. Again, this is crucial. It's a crucial POC, proof of concept, that warp fields may be physically produced and generated. But there's tons of challenges remain to scale this. But it does give credibility to the concept. Now, on top of that, continued research led by scientist Harold White aims to optimize and reduce the immense energy requirements that are proposed from this POC in early warp drive models through innovative geometry and design concepts. So again, we're super, super early to this, but we've overcome a key hurdle where we thought it was theoretically impossible, and it is theoretically possible now. So that is a huge leap, I would say.
Absolutely, it's a huge leap, but being theoretically possible and then doing it are two different things. Like,
Yeah.
you know, they say time travel is theoretically possible, but I've read an article saying it isn't now. But you know, everyone's so another theory will come along and say something different.
Yeah.
But let's assume it's theoretically possible now.
Yeah.
What are some of the challenges of trying to get a warp field to a useful size?
Yeah, well, the first thing is going to be containment, right? You have plasma warp bubbles at EagleWorks. They were only microscopic, which is far below the scales needed for vehicles. So containing and shaping those exotic high-energy fields poses daunting engineering obstacles. And the other thing that I was thinking of, too, if we're talking about these warp bubbles, is that the same thing as I'm just going to digress here for a second. Is that the same thing as a force field? Maybe, I don't know. But the other challenges are stability. So what they saw was small disturbances grew bubbles unevenly. So larger fields are going to require exquisitely detailed control to maintain distortion geometry far from equilibrium, or effects could dissipate way too rapidly. Energy input. So the bubbles required intense laser power, and they're likely impractical at larger sizes at this point. So alternative mechanisms with constant distributed energy profiles must be developed. Material stresses. So space-time curvature induces enormous pressures between normal and warped regions. So there's so many theoretical stresses over prolonged use. And there's tons of other ones: field uniformity, guidance and control, again, safety testing. What happens if you're in warp and the bubble collapses, right? So there's so many different there's a lot of validation, extensive validation, that's going to be required before we can even start to think about this at scale. I think you're on mute there, Craig.
I was on mute, sorry, and it kept going on off here. To answer your question, is a warp drive a warp bubble a force field? No. If anything, it's a gravity field, as we were just talking about, because it's only if the field manipulates in specific ways in order to move a ship faster than light, rather than protecting you in one spot.
Okay, interesting. So yeah, and just to get back to like the theoretical ability to actually manipulate space-time, it's going to require breakthroughs in exotic phenomena like negative energy, matter, which we have no known means to produce it yet. So, and the other thing too is the one thing, and if you think back to your Star Trek days too, is we're going to need compact fusion or antimatter drives, potentially, to supply the kind of energies that's theorized in order for these to produce these at scale.
Yeah, because Joseph Agnew's testing this theory, right? And this requires a massive amounts of energy. But I don't know what massive amounts of energy is. You say fusion drive. So if we're trying to do it here, do we need multiple nuclear reactors to create, something? Or is it
at scale? Potentially, that might not even give us what we need. Who knows? I didn't explore what the power draw was. I don't know if it talked about it in the article. I don't think it did, but
and it was hard to say because we're talking about microscopic fields, right?
Yeah, but you can always scale that up with an equation, right? And that's another theoretical equation, or a theoretical number, because it might not scale might not scale linearly, or it might scale exponentially. Who knows? I'm not an expert in warp drives, so I wouldn't know.
So we talk about this and say, all right, so it's theoretically possible. They're working on figuring out how to do this, create warp drives, warp bubbles. We need a massive amount of energy. So we're talking about compact fusion, or if we're in the theoretical world, antimatter drives. Where are we with any of that technology? Yes, as your keyboard goes crazy.
Yeah, no, I'm looking it up where we are with antimatter, because I have no clue.
I figured.
That's a good question. So what they're saying is it's still experimental. So CERN is good. I'm glad CERN came up, because that's what I was hoping for. They're capable of producing antimatter particles like antiprotons and positrons through high energy particle collisions, although quantities remain tiny. And I think there's a huge thing with containment of antimatter, or that just might be from the movies. But so containment using magnetic and electrical fields. Scientists have been able to isolate and hold cohorts of antimatter atoms like anti-hydrogen for over 1,000 seconds. Previously, they would annihilate in microseconds, so they're getting closer. Experiments continue probing questions like whether antimatter obeys all physical laws as the same as normal. So far, the tests have shown no anomalies. But the energy potential, this is why they're saying the energy, 1 gram of matter of antimatter annihilation yields 1.8 times 10 to the 13 joules of energy, which is huge. It's so 1 gram is about the output of a small nuclear bomb. So that's why antimatter would definitely be useful for these, for the warp drive.
Yeah, because there's a massive amount of energy. I know they're working on some sort of warp field interferometer that aims to detect and generate warp bubbles at NASA. So you know that people are taking it seriously when, you know, CERN and NASA are working on these things.
Yeah, absolutely. Yeah. We just, I think, again, there was, I can't remember what movie it was where they had antimatter in a containment kind of tube,
Yeah.
and that if that containment broke, that it would destroy the world or something like that. I can't remember what it was, or create a black
And
hole. I don't
who
think.
makes these things that, like, let's just put the world's most destructive thing in this vial that someone could just drop?
Yeah, exactly. Who knows? That just might be a movie picture concept that's not real, but we are getting more real with a lot of these movies nowadays, especially with Interstellar, where I sorry digress, but what they came up with as far as how to represent black holes is now being used in science, which is pretty cool.
It's always interesting when these new theories change. I wasn't necessarily a fan of Interstellar, so, you know, the fifth dimensional bookshelf did it in for me, but that's a whole other discussion.
Fair enough.
But it doesn't mean that some of the sciences makes you think about it. And let's face it, science fiction leads science in a lot of ways. The stuff they invented in Star Trek is now reality. We now have cell phones. We can call Scotty and stuff, and we can do a lot of the things. We can talk to computers. We can, you know, things we couldn't do back when they came up with this in the 60s.
Yeah. The one I'm worried about is the beaming technology, because from everything I've read is in order to do that, they would have to completely destroy you and duplicate you at the destination. So it's a copy of you every time that you are beamed.
Yeah. So the question becomes, though, we say have to destroy you. Do they actually have to destroy you, or do you physically atoms break down in the process of transfer, or just because we're cloning you, we have to put a bullet in your brain on this side so the two of you don't exist?
No, I think it physically, well, based on just the concept, theoretical stuff that I've read, is it'll break down your matter or your atoms and then redraw you. I don't know, just I don't even know the word for it.
So that's got to be excruciating. It rips you apart at the atomic level and destroys your very being, then puts you back together.
Exactly.
It doesn't sound like something I want to go through.
No,
but at the same time, we did the talk on teleportation, and based on this whole same technology, there's no reason why they couldn't teleport me from my fat body into a healthy muscular body. So I might go through some pain for that.
Yeah. Well, we are getting close. I think we talked about this is consciousness, digital consciousness or artificial consciousness, right? And uploading your consciousness. How many times can I say the word consciousness? But it's where I think Elon Musk was talking about that, is he wants to do that.
So, you know, are we talking about time travel when we're talking about warp drive?
So potentially, because as we get closer to the speed of light, it's essentially like traveling back in time because of the relativity of it. But I don't know if the warp bubble is going to help solve that. But based on the math and the physics, the closer you get, the slower time goes by, I think, as it is.
Time dilation.
Yeah, time dilation. Yeah.
I've watched some sci-fi in my time. Yeah, that's why I wonder, because it says, you know, we're talking about this, and this whole warp drive suggests that warping space-time to achieve speeds exceeding light, which is what you need if you want to travel great distances. Because it doesn't necessarily mean, well, it does actually. If I travel to Mars at the speed of light, or faster than the speed of light in warp drive, that I'm getting there, you know, in a millisecond, where light takes maybe minutes to get there. Am I just wove 10 minutes back in time, as an example?
Yeah, potentially. And the other thing to think about too, since we're talking about time dilation, is the difference in time dilation between Mars and Earth. right? So Mars has a weaker gravity than Earth due to its smaller mass. So gravity at the equator is about 38% of Earth. So weaker gravity means that time passes more slowly, according to a time relativistic, I think it is, time dilation caused by differences in gravity potential. So on Mars, time passes about 0.004% slower than an equivalent period on Earth. So for every 1 year that goes by on Earth, a Mars year would be about 0.004% longer. So for every 100 years that pass, I know it's not a huge thing, but for every 100 years that pass, about 100.004 years Mars years will elapse.
And so if you went the other way in a heavy environment, it would be longer?
Yes, shorter.
Shorter. Okay.
Yeah.
So if I was in a heavy environment and I was 20 Earth years old, I might only be 16. Let's just throw something out there based on.
Yeah. And that just goes to show how accurate Interstellar was, because they were showing that. Remember, one of the planets that they were on, because they were so close to the black hole, time was passing by much faster.
Every sci-fi that goes on the edge of black holes shows this. So I'm not, don't say they were revolutionary.
Try to get you on board with Interstellar there. Come on.
I get that you like the movie. You don't have to keep pushing it on me. But no, the concepts are very interesting around like what we're doing here, because we need, if we actually want to travel to other worlds and populate planets, we need a warp drive that knows close to speed of light won't do it.
Yeah.
Because it's just going to take generations to get anywhere.
Yeah.
So we need something like this. The question now becomes, are we going to be warping across the planet? Like, okay, we got a little warp bubble. I'm in Japan, but I got a meeting in New York, and I'll just walk through this little bubble and I'm over there.
Hey, that's a great idea. Yeah. Who knows? But isn't that once we get warp technology, that's when we'll be visited by the Federation? I think that's what it is. You have to get to warp technology before.
Well, it depends what you read. If you like to read So Long and Thanks for All the Fish, I can't remember his name, the guy who did Hitchhiker's Guide to the Galaxy.
Oh, yeah. What's his name? Anyways.
Yeah, we're gonna all get blown up the Earth's gonna get blown up to make room for the interstellar highway.
Yeah. Oh yeah, that's right. That's what it was. I'm gonna read that, yeah.
So yeah, but we're gonna, if there's aliens out there, eventually we'll get their attention as we start warping this, creating warp bubbles and destroying space time everywhere.
Yeah, for sure. Yeah.
All right, this has been interesting. I like where this is going, and I want to delve heavily into where warp drives and space time in a future episode. But we got a lot going on, and we're getting close to the hour here. On Wednesday, we're going to be talking about this Scale AI program. What's going on with it, John?
Yeah, so Scale AI is an awesome digital supercluster, government funding, non-dilutive. If you've got a project that is AI, but as it's trying to solve a supply chain problem, join up, let's talk Scale AI, let's talk projects, and we'll talk about how to access that funding.
Yeah, and the reason why John and I are a little tired today is last night we had our monthly startup investor drinks. The next one is February 29th, and it'll be posted by tomorrow morning. I'm a little tired today. I'll get it up this afternoon, but if you go to startupdrinksto.com, you can check out and grab a ticket there. Join John and I. Last night we had, I don't know, almost 70 people, 65, 70 people out. And that's usually an average turnout. Next month, I expect about 70. March will be big. We'll probably be close to 100 just because of the situation. Come out and join us. It's a great event. Meet some fellow entrepreneurs, talk tech, talk entrepreneurship. It's amazing. The other event I want to mention coming up is if you go to mentoringmagic.ca, we have a co-founder matchup event with Futurepreneur and Consulta, where it's going to be an interactive event. If you're in Toronto area and you're looking for a co-founder, come on out. Go to mentoringmagic.ca and sign up. Get your ticket. There's a form there asking you what skills you offer and what skills you're looking for, because are you a developer looking for a business development person? Are you a salesperson looking for someone to help you develop what it is you're looking for? And we'll start doing some matching. There's going to be some games and some stuff, and we're going to have Siavash from Shakarian Law and talking about co-founder prenups, just so you understand what kind of stuff you're getting into as well. It'll be a great night out, so join us there. All our other stuff is at TorontoStarts.com. If you want to work with me, go to TorontoStarts.com, click on the Startup Coach page, book a discovery call, and we can chat. If you want to reach out to John Irwin on LinkedIn, reach out if you want to talk about funding. What else?
Funding, if you want to geek out, if you want to talk government funding, non-dilutive, that's my area of expertise. If you need some coaching, other than specifically as it relates to grant strategy and things like that, feel free to reach out. And I actually do have an event that I'm attending to promote too. So on February 20th, I'm going to be taking part in a roundtable with two other phenomenal people, talking about HR, branding, and funding. So
the Creator Club event, King Street Media.
Yes.
Yeah, they're great.
Yeah. So Eric,
where do they go?
Eric's putting that on, and he's a phenomenal guy. What's that?
Where do they go to find information about that?
Message me on LinkedIn. I don't have the link. I'll send it to you for next time because it's we'll be able to talk about it. Yeah.
You sent me that stuff.
I was prepared to talk about an event for once, but not the link. But we'll get it to you.
Absolutely, we'll get it down. If I'm happy to throw this stuff on the screen so people can grab it. Anyway, that's it for this episode of Futuretech Live. Don't forget to check out the podcast at TorontoStarts.com/Futuretech. Where we break these down into episodes and you'll never miss one topic we talk about. And that's it for this episode, and we'll see you next time.
Awesome. Thanks, guys.
Wow, that was amazing.
See you later, alligator.